bit raspy. Hopefully it won't give out on me tonight. So this is our fourth presentation in this 5-part webinar series on breeding better sheep and goats. Tonight I want to focus on performance evaluation, and that's going to encompass some different things. Just to let you know about our final webinar next week, what I plan to talk about there are what I consider the more advanced methods of genetic improvement, and this includes EPDs. We're not going to get into EPDs or any of those things really tonight, but want to focus on them, look at some of the other things that aren't even necessarily available in this country or not available yet, but look at kind of some of the more advanced ways that we're going to continue to improve livestock genetics. The things we're going to talk about tonight, everybody here can basically do. And a lot of the stuff hopefully you are doing. If I have to cough or sneeze, I might pull away from the mic and there might be a little bit of silence, hopefully silence, because I don't want you to have to hear that. I've got something to drink, so hopefully I'll keep my voice going. As I mentioned, we're going to talk about performance evaluation this evening. And kind of what I wanted to focus on is to talk about the sheep and goat industry as compared to other animal industries lag pretty far behind in terms of genetic improvement. Especially the goat industry, although the exception to that is the dairy goat industry. That's probably the most advanced component of the small ruminant industry in terms of performance evaluation, performance record keeping, some of these advanced record keeping methods that we'll talk about next week. The sheep industry is a little further ahead of the meat goat industry, but not by much. Basically, we're still in this first column. We tend to focus on phenotype. You know, and phenotype, of course, is not genetics. Genetics is a component of it, but it's a combination of genetics and the environment. So when I go to a farm and I buy a ram or a buck and he looks really good, I'm probably getting a combination of genetics and a combination of the management of that farm. Where we'd like to go to, if you're interested in making genetic improvement in your farm with your breed, because sometimes I think we have to think beyond our own farm. If you have a lot of interest and pride in the breed that you raise, then we also need to be concerned about making an improvement in our breed, which will indirectly hopefully help us, but it's just very important. And where we need to focus, again, is separating out the genetics from the phenotype. We need to focus on the genotype and really try to get at the genetic aspect. And we can do some of that on the farm. We don't necessarily need all the technologies or techniques that we're going to talk about next week. For the most part, we pick breeding stock by how they look. And I'm not saying that's totally unimportant, and that's going to kind of be the last thing I talk about tonight, but we really need to get away from just looking at the animal and assuming that, well, if he looks like that, all of his offspring are going to look like that, or if he looks like that, his does or his ewe offspring are going to be very productive. We can't tell that by looking at them. We need to move towards evaluating animals, particularly the males, on how they perform. How do they grow? How do they handle parasites? How big is their ribeye? Things like that. If I'm just looking and guessing to actually doing some measurements. And along the same lines, we need to get away from always just being subjective, again, what we see. And I'd be the first one to admit there are certain traits that we are interested in that are economically important traits that we still have to subjectively evaluate. You know, we can put numbers on it, but those numbers still may be subjective versus objective criteria, which would be pounds, kilograms, you know, number of lambs, percentage, you know, real numbers. So we don't want to totally get out of the first column, but we need to make advances towards that second column, focus more on genetics, look at performance, and be more objective in the things that we're looking at. Okay, so what do I mean by performance evaluation? This is what we're going to talk about tonight. There's basically two ways that we can evaluate the performance of our sheep and goats. We're going to talk about, again, the first column. The second column we're going to be focusing on next week. We're talking tonight about how we evaluate an individual animal by looking at his individual records, his individual measurements. That could be weights, it could be pounds of milk, it could be the weight of the fleece, the staple length, it could be ultrasound data on back fat, ribeye area, it could be things related to parasites like fecal egg counts and FOMACHA scores. It could be data that we collect or we create from the original data. Adjusted weights are created from original data that we collect, as are performance ratios. So we're going to focus on the individual animal. There's going to be some occasions where we can incorporate records of, say, the sire. We can kind of look at, we can get a little bit more information than just the one individual that we're selecting on, but for the most part we're looking at the individual and the data that we can collect on he or she. Next week we want to get into where we're still collecting some of the similar data that we see in the individual records, but we're using that data, the data from relatives, to actually predict the genetic performance of progeny, of future progeny or future offspring. EPDs, EBVs, the DHIR is the Dairy Herd Improvement Program. We'll talk about what those acronyms mean and what those things mean and how they can benefit you, even if you don't yourself get that data on your individual animals. I know when I buy a ram, my ram usually has EPDs. Even though I individually don't participate, you can still benefit from that. And that's why I say we also need to be interested not only in improving our own livestock, but if we're a seed stock producer or a purebred producer, or we show livestock at the fair, we ought to be concerned about improving our entire breed. When we talk about performance evaluation and genetic improvement, obviously we need to set goals. Of the people that are participating tonight, we've got people from different parts of the country, outside of the country, people who raise sheep, people who raise goats, people into it for commercial, economic reasons. I know at least one person mentioned that they have pets. We've got dairy goats, we've got meat sheep, we've got all different kinds, wool sheep. So you need to decide what's the primary reason that you're raising sheep or goats. Because you really can't go any further in terms of genetic improvement or performance evaluation if you don't first ask yourself, well, why am I raising sheep? So if I'm raising sheep commercially or goats commercially, whether it's meat, milk, or fiber, what are the traits that are going to help me be the most profitable? If you're a seed stock producer, you raise a specific breed or even a specific cross where you sell breeding stock, you sell rams, you sell bucks, you sell ewes, I think it's really important that you look at the breed that you have and determine what its role in the commercial industry is. Now, just because you show animals or you sell a lot of breeding stock doesn't mean that your breed doesn't have a place in commercial production. But you need to know what that role is so you know what traits are important to the commercial industry and should be important to your breed. Because what you have to do when you figure out the role of your breed or breeds or cross is which traits are most important. Again, if I'm a commercial producer or I'm not a seed stock producer, what are the traits that are most important to my herd or flock? But also if I'm a seed stock producer, what are the traits that are most important to my breed? This next slide, I just kind of took a bunch of type of animals you might be raising or different production emphasis to look at what are some of the different traits that you might be focusing on. They're not all the same. The perfect example is I raise a maternal breed of sheep. Its role in the sheep industry is to be the dam. So I focus on reproductive traits, fertility, prolificacy, mothering, milk production, litter weight, fitness, meaning I want a female that's moderate size, don't need to trim her feed a lot, don't need to deworm her a lot. Conversely, if I go to the other side of the screen where I say terminal sire, I might think of that as a Suffolk or a Boer goat or a Southdown. The role that that breed has in its respective industry is to cross onto these maternal breeds to produce superior crossbred market animals. So while reproductive traits aren't unimportant, they aren't as important as the traits which are going to help me produce highly desirable market animals. traits like size. And I use the term size to indicate that, well, that could be length of body, that could be the appropriate size for that breed. But growth rate could be overall growth rate, it could be early growth rate. Carcass merit's a very important one. Again, I'm not saying carcass merit isn't important on a maternal breed, but it's far more important on a terminal sire breed. These males that produce these crossbred offspring, we need high survivability in the offspring, and we need rams or bucks that have a strong libido or sex drive. They need to get the ewes pregnant. Lots of other reasons out there why you have sheep or goats. I know we've got several dairy goat producers. Well, I'm looking at, again, very different things. I'm producing and selling milk, so I'm looking for pounds of milk. If I'm making cheese, I might be more concerned about increasing those components, protein, fat. As a dairy producer, I'm always concerned about udder conformation. If I'm interested in fiber, I'm looking mostly at fiber traits. Might be very different if I'm selling commercial white fiber versus I'm niche marketing to hand spinners. I might be looking for I will be looking probably for very different things. If I'm a seed stock producer versus a commercial meat producer, again, the things could be quite different. And the one that's probably just as different as any of them is if I show. I grew up showing sheep. I thoroughly enjoy it. It has an important role in the sheep and goat industry, but I'm probably going to be looking at different traits. Again, I'm not saying reproduction's not important. I'm not saying milk production's not important, but the traits that are going to be the most important to me are going to be the ones that give me success in the show ring in terms of my placings, and therefore my ability to sell breeding stock. So things like how the sheep looks, how the goat looks, size, conformation, structure, eye appeal, breed character, all those things. Structure is important no matter what, but the very fine points of structure can make a big difference to people that show. So we got to find our place. What are we as a producer? And then again, if I'm a seed stock or purebred producer, what is the role of my breed and what are the traits that I should be emphasizing? And I hope this slide didn't confuse anyone. I'm just kind of trying to think of the different reasons that people raise sheep or goats and some of the different breed types that we have out there. If I take a maternal breed of sheep and select it all on size and growth rate, or I'm likely to lose a lot of those maternal traits. And then the same thing if I selected, if I had a flock of sheep that I raised to sell fleeces to hand spinners, if I selected totally on those commercial fiber traits, and one of them, which I don't have there, is the freedom from black fiber, that kind of goes against what I'm doing in the niche market. So you got to know where you fit. And that's very important to making genetic improvement and evaluating the performance of our animals. So you've determined your role, you've determined what the purpose of your enterprise is, what the role of your breed may be. The next question is, are those traits economically important to your farm? We can joke all we want about show animals and then picking the prettiest one. We'll say, well, that's not an economically important trait. Well, it is in the show ring business. An animal that does well in the show is going to translate into the opportunity to sell breeding stock for the show ring, so it is an economical trait. The next thing is, can the traits be measured, objectively measured ideally? And again, not everything can be, but we want to try to favor traits that we can objectively measure. We can measure some of the visual or show ring traits. We can measure things like height and width. That's basically what linear appraisal is in dairy goats. They're looking at visual traits and they're putting numbers on them. But we want to know these traits. When should I measure them and how can I measure them? Will they respond to selection? It's not going to do you any good to say, well, I want this. You got to know how you're going to get there. And we talked about how responsive traits are to selection based on heritability. Some traits are going to respond better to crossbreeding, and that would be the better strategy. Some traits you can approach it either way. I'll give you an example in my flock. I believe one of the most important traits is milk production, because milk production is going to translate into heavier weaning weights, which is going to give me more quote to sell. Well, I can do that in two ways. I can crossbreed, which I'm doing, with a dairy sheep to try to increase milk production, and I can also select for it, which I've been doing all along. So you can sometimes approach the things from two different directions. And as I mentioned last week, performance evaluation starts with animal identification. If you've got 5 goats or 5 sheep, you pretty much know them by heart. But the more animals you get, the harder that gets to know, and we want to put identification on them. Ideally, we'd like it to be permanent, but we all have different preferences of what type of identification that we need. Things like ear notches or tattoos and even electronic ID are much more permanent than ear tags. Ear tags vary in their retention, whether they can be tampered with. Some people will double tag so as a protection. Personally, I figure that the scrapey tag that I'm required to put in, and I know they are in Canada as well, I look at that kind of as a second ID. But I only have a flock of 40. We have 80 bucks on test. If somebody loses a tag, I either know who it is or I can figure it out pretty easy. But as flocks get larger, or as you go from year to year and you just simply can't remember anything, these identification methods are pretty important. Some of them, like paint brands and neck chains, can still be used, or they can be doubled up with some of the permanent methods of identification. I know a lot of dairy animals will the goat will have a tattoo, but they'll also have a neck chain on it, so it's easy to identify. But identification is step one to doing any type of record keeping. One of the first things we do when the bucks come on test is we put an ear tag in them. We put one of our ear tags in them so that we have, because everything keys on that number. Every piece of data that we collect keys on that ear tag on that goat. So it's very important. Of course, the next thing is you can't really do any of this without keeping good records. And hopefully everybody is keeping records. I think there's certain records we understand that we have to keep by law. Obviously, we now have to keep records of the scrapey tags that we apply. You need to keep records on medicines that you give. Not necessarily that somebody's going to come inspect them, but if you don't keep a record on the medicine that you give, how will you know if you take it to market whether that medicine has had time to clear the system? So certain health records we already have to keep. Everybody should keep some basic, what I call the reproductive records, sire, dam, date lambed, kidded, birth type, all that kind of stuff. They're pretty easy to keep. What additional records you keep and data that you collect, again, is going to depend on your production emphasis. Dairy, meat, fiber, show, your breed. Do you have Suffolks? Do you have Catons? Do you have Boers? Do you have Kikos? Do you have Angoras? That'll have a bearing on what records that you keep and data that you collect. Hopefully, like I said, everybody will keep the basic birthing records, the basic health records. But beyond that, it's going to be it's going to depend on some of those specific questions you ask of yourself. For people with large flocks, and I don't know that we have very many people that have participated in the webinars that have really large flocks, but sometimes record keeping is done on a portion of the flock. Breeding stock or replacements are pulled out of a portion, and so they'll keep records on a portion. The other thing you can do is, if you don't really want to do record keeping, or say, I'll give you a perfect example, you're interested in getting parasite data but you don't want to do all that. If you put a buck or ram in a performance test, you're basically, one of the things you're paying for is to get that data collected. So there's certain information that you could get about your animals by putting them in a performance test. There's a lot of options for keeping records. Obviously, from everything from a computer to the good old-fashioned way of a pencil and a notebook. The picture of the chalkboard down there, that was some milk records in China. But I recall from being a kid, we had a blackboard, actually it was green, in our barn, and that's where we kept our lambing records. My dad did it up to the year he stopped raising sheep, which was just this year. Of course, those records eventually have to be transferred onto something more permanent. But there's just a lot of different, ways that you can keep records. I've seen people keep them in amazing ways. A lot of times it's just making sure they get transferred to where they can be used. There's a lot with technology these days. There's a lot of things that can help you with your record keeping. You can kind of do your own thing with spreadsheets and databases. You can buy software for keeping records. I know that Canada has a program online for records, and there's a couple of universities in the South. They won't collect your records. I mean, you still got to collect the data, but they will process it for you. You can send them all your data, and they will calculate adjusted weaning weights and things like that. I think it's Kentucky and Tennessee that'll do that. Shoot, if you send me your weaning weights and the information needed, I'd be willing to calculate adjusted weaning weights for you as well, or ratios. We're actually going to go over that tonight because I think those things are really basic record keeping that you should use or should do, particularly if you're producing meat animals. So let's just go through these record keeping methods a little bit. This is actually out of one of my little pocket record keeping books. I think this is from a couple of years ago, and you can just see there's a column to put the ewe number, the ram number. I always put the ram's name. I always name the rams, not the ewes. The date they were lambed, the sex of the lambs, the lamb ID, and then I have birth and weaning weights. Shepherd magazine will give record keeping booklets, their hand pocket, for free, and there's a lot of other places that have produced these little pocket record keeping books. I always have it in my pocket. Eventually I'll transfer that data to something else, but I just keep it with me when I'm in the barn and fill all that data out. And if you at least do this is a start, and these are the type of records that you need to keep. If you wanted to record other things, like you wanted to give her a numerical score for how good a mother she is, a numerical score for her ease of lambing or kidding, unassisted, I pulled a leg out, things like that. You could add stuff, you could do more, but this is the minimum of what you should keep. Not everybody does birth weights, and when we get to doing some adjusted weaning weights, there is a way around that. But I always like to do birth weights because it's kind of a measure of my management. If lambs are too small or lambs are too big, I need to start questioning my nutritional program. What I typically do with my records, and this is from a couple of years ago, is I will take the information out of that pocket record keeping book and I'll transfer it into a spreadsheet. You can see some of the same things that were in that record keeping book, but then I'll start to put the weight information in it. I'll put down the date they were weaned. I don't always weigh on the same day I wean. I should probably weigh and wean at the same time, but I don't always get that done. I'll use the spreadsheet to calculate the age of weighing, and then I'll calculate an average daily gain, the corrected weight, and we're going to do these by hand. The corrected weight, I'll use the spreadsheet to calculate. The adjustment factor, again, we're going to do this by hand. I'll look that up and just plug that number in, and then the spreadsheet will calculate the adjusted weaning weight and the weaning weight ratio. I can rank my lambs. I can rank the lambs by breed, by sex. I can calculate something similar for the dam in terms of her litter weight and that sort of thing. But up to this point, have been using spreadsheets or a spreadsheet. Sorry, I keep taking a pause to get a drink of water because I think if I don't keep drinking water, I'm really going to lose my voice. There are certainly a number of record-keeping third-party software programs out there. The URL from my website, sheepandgoat.com, there's a link to some flock or herd record-keeping programs. The page actually lists any software that I have found that's relevant to sheep and goats. So it includes not just flock or herd record-keeping, but also balancing rations, some economic things, even keeping track of fares. This happens to be the screenshot from a program called Flock Filer. I think somebody mentioned last week that they do use this one. One of the things I I don't pretend to know about all these programs, and certainly not their most recent versions, but in the past I could never find one that I liked because I wasn't looking for a program to just store data. I was looking for a program that would analyze that data and give me things like adjusted weaning weights, weaning weight ratios, lifetime production on ewes. Well, this one seems to come closer than other software that I've looked at, but again, some of the other ones I haven't looked at in years. So this is just an example. The other good thing about this program, and I don't necessarily be meaning to endorse it, but you can download a free trial version, and it's a full version. And I think that's true with some of the other ones. So you can kind of look before you buy to see if it does what you want. I know that Canada has a fair number of programs as well. In fact, in some ways, I think Canada is ahead of the U.S. sheep industry in terms of performance evaluation. But there's a program called U-Bite, and again, there's a program that does records, I think, online. So if this is something that interests you, go to this website, go to the individual sites, have a look at their program, see if they do what you want. Some of them will integrate financial record-keeping software into them as well, and just see if you can find what you're looking for. The other thing I think is important, and it gets back to me saying I've never really found software that I really liked, is because I don't find records very useful unless you use them. Well, you know, she had 2 lambs, she had no trouble lambing. Unless I use that information, I don't see the point in keeping the record. And so we have to take that collection of data to a further step to actually use it to make decisions. Use records, whether it's our own records or the records of another farm, to choose a ram or buck to purchase. On our own farm, use our records to select our replacements. I do that every year. I select my replacement females on the basis of the records that I keep, the records that I have on their mothers. Use the records for keep cull decisions. You know, am I going to keep this doe? Am I going to keep this ewe? Well, gosh, she raises a single lamb or a single kid every year. You know, you may be able to remember that, but if you don't, the records are going to clearly show that she's not doing the job. If you castrate males and you're a seed stock producer and you want to make sure that only your superior males get out there, you may also use records to make decisions to castrate. Now, I'm not one who thinks you should wait till you get a weaning weight or 120-day weight before you castrate a male by any means, because I think castration should be done young, but you can look at kind of the family, more of the family records to make some of those decisions. The records need to be, or the data needs to be properly analyzed and used if it's to be effective for genetic improvement. You know, we don't usually just look at raw numbers. We have to put those numbers in the right context. We have to make adjustments that are necessary that enable us to use them to advance the genetics in our flock or the genetics in our breed. One of the most important aspects of performance evaluation is a contemporary group. And probably one of the most misunderstood. Because when we're talking about genetics, first we have a hard time separating genetics from the environment. And then when we think we've got the genetics kind of pulled out, then it's very important that we compare apples to apples and oranges to oranges. We can only make comparisons of animals that are in the same contemporary group. You can't compare animals that were born in the spring with animals that were born in the fall. You can't compare animals that were given different nutrition. You can't compare how a doe milks if they're given, 2 does are given completely different nutrition. If I were to define a contemporary group, and here I'm talking primarily about a group of lambs or kids, fiber or meat type lambs or kids, a contemporary group would be basically the same breed, or a percentage of the same breed, born ideally kind of plus or minus 2 weeks, 2 weeks either way. And that might be a little optimistic. You might have to stretch that a little bit, but basically we're saying born within the same month. They need to be raised at the same place, in the same flock or herd, be of the same sex. Now we do have adjustments for sex that sometimes we don't need to separate those out, but our comparisons need to be within sex. And they need to be managed the same from birth until time of management. That's a lot of stuff. But if you have differences, and here's some of the differences that can affect contemporary group, you're not getting to the genetics. You are not making a fair comparison. Again, breed or breed percentage. Do you think you should compare a purebred to one that's half this breed and half the other? Do you think you should compare, a Shetland to a Dorset? So they need to be the same contemporary group. Again, the sex. We know that males grow faster. We know that males are leaner. Okay, they should be born and kidded at basically the same period. I think I've indicated that I've split my lambing season into 2. That means I cannot compare the lambs that are born in February with the lambs that are going to be born in late March. They're different contemporary groups. If I raised them in different places, if you had different locations on your farm, and obviously how you actually manage them. If I have a group of kids that I dewormed them all at weaning, and then I had another group of kids that I didn't deworm at weaning. I had lambs that I crete fed versus lambs that I don't. They are not in the same contemporary group. Anytime an animal gets preferential treatment, it should be placed in its own contemporary group. This picture you see up here was of a goat, and I know Jeff will remember this goat. He darn near died. He spent 2 weeks in a pen in our pasture test. Well, that 2 weeks, he didn't die. And when he actually went back into the test, he did outstanding. But he was no longer in the same contemporary group as the rest of those bucks because he got that preferential treatment for 2 weeks. On my own farm, I give triplet mothers an extra pound of grain compared to those raising twins. Puts them in a different contemporary group. So just think about how different things are affecting the performance of that animal. And again, make sure you compare apples to oranges. Sometimes, if you're truly dedicated to genetic improvement, you need to make decisions that increase the size of your contemporary groups. For example, I shouldn't, from a genetic improvement standpoint, I should keep the twins and triplet moms together to make those selection decisions. So sometimes you actually make a decision. Maybe it'll compromise performance, but it won't compromise determining the genetics of that performance. And then the other thing, like I said, we don't necessarily look at the raw data. If you tell me that you had that your buck kid had a weaning weight of 60 pounds, I couldn't tell you if that's good or bad. I don't know how old he is. I don't know whether he was a twin. I don't know how old his mother was. Okay. You told me his ribeye of a lamb was 4 inches. Again, I have to be able to put that data into context. Sometimes we have to take the data that we collect and we have to adjust it to remove environmental effects or adjust it to a standard, to some sort of standard. And I'll give you a couple of examples. If you take weaning weight, which is probably one of the most important performance criteria for those of you raising kids and lambs. Not if you artificially raise them in dairy so much, but if you raise fiber and meat kids and lambs, this is one of the most important traits. So when I weigh that kid or lamb at weaning, my standard that I'm going to compare them against is a single male offspring raised by a 3 to 6 year old dam. The reason they chose that is because that 3 to 6 year old dam is the most productive We know that there are other environmental factors that make young mothers not as good, and then after the age of 6, on average, their production as well starts to decline. When we measure things like ribeye area or loin-eye area, there's certainly a large genetic component to that, about 35%. But one of the major environmental influences on loin-eye area is how big the lamb is, or how big the kid is. The bigger he is, all other things equal, he's got a bigger ribeye. So we tend to adjust ribeye area for a common weight of a market lamb. And I'm sure there's some different figures. I don't know what they use in Canada, but about 125-pound lamb. And we would need to be sensitive to breed, because if I'm doing the same thing with a Katahdin lamb, by the time that Katahdin lamb reaches 125 pounds, he's going to be pretty fat. So we would use a different weight. In fact, there's a hair sheep ram test in Virginia. They ultrasound the rams to get ribeye area, and then they adjust them to 100 pounds. So these are just standards that allow us to compare. Even a trait like scrotal circumference, again, it's kind of like ribeye area. It's got a large genetic component, but also it has a lot to do with the weight of the male. So the bigger the male is, the larger the testicles. And so again, sometimes we got to think about those kind of things. What I want to show you now is basically how to calculate adjusted weaning weights. And again, this is something I think you should do if you have meat or fiber sheep and goats. If you have pets and you want to see how good, or if you have something to compare it to, you have a couple pets, you can do these simple calculations. The Flockfiler program will do these calculations. The universities of Tennessee and Kentucky will do them for you, but they're real easy to do, whether you do them by hand or whether you plug the formulas into a spreadsheet. So I just want to show you simply how you would calculate adjusted weaning weights, because it's also a way to kind of show you why we do these adjustments and how we kind of tickle out what's genetics and what's environment. Because again, that's one of the hardest things we deal with, is how to separate the two. How do I know that lamb? I can actually tell you that was a quad lamb. How do you tickle out the genetics? Because as a quad lamb, obviously he wasn't going to have, you wouldn't have expected him to grow as fast as a single lamb. What we typically do to calculate adjusted weaning weight, the first thing we do is, because we don't always weigh lambs when they magically hit 60 days of age or 90 days of age or 120 days of age. We usually weigh a bunch of lambs or kids at the same time. So if we do that, we have to adjust the weights to these common ages, 60, 90, or 120. We tend to use 60 days for early weaning. We tend to use 120 days for later weaning, but you can kind of choose. And breeds actually have chosen in the past which they consider to be a weaning weight. So the first thing we do is we figure out, in order to get that common weight to that common age, we have to determine how well that lamb has gained, his average daily gain up to his weaning weight. And then we take that average daily gain and we multiply it by that common age, and then we add birth weight back in, and then we've got and then all the lambs or kids would be equal. This would be a 60-day weight or a 90-day weight or 120-day weight. So first we have to adjust the age. The second thing is we have to make these adjustments for environment. And the things that we look at are sex, although we don't have to adjust for sex if we simply compare only males, only females, and only wethers. But typically we have adjustment factors for the sex of the offspring. I think I saw in the chat box somebody mentioned the age of the dam. That's a really, really important adjustment factor. You may not think about it, but again, I want you to think of a yearling doe or a 2-year-old ewe. They don't do as good a job as a 3- or 4-year-old ewe. And for those of you who keep ewes and does into their later years, you will tend to see a decline in production on average. So there is an adjustment for the age of the dam. They even do that for beef cows. The other thing, and I think everyone realizes this, is the type of birth and type of rearing. Again, the lamb in the picture is a quad. In no way do you expect him to grow as fast as a twin or a single. And if he does, his data on his adjusted weaning weight is going to really show that he's a genetically superior lamb. So we expect males to grow faster than wethers, wethers to grow faster than females. We expect twins to grow faster than triplets and singles to grow faster than twins. And ewes that are between the ages of 3 and 6, their lambs are going to do the best because they're at the prime of their production. So what do I mean by these adjustment factors? By using these adjustment factors, we are trying to remove the non-genetic factors that are affecting the performance of that lamb. And it enables us to compare apples to apples. This is a chart that very widely used, produced by its source is the Sheep Production Handbook. And you can see that it has different things for the different ages, the different sexes, and the type of birth and weaning. In the case of that lamb on the previous slide, there is no, well, I say there's no place for him, but the quad lambs would fit right in with the triplets. I think I glanced in the chat box about somebody asking about orphan lambs. They really don't fit. They are their own contemporary group. In most cases, they don't do as well as the lambs that the dam feeds, but I think with the good milk replacers and good management, I'm finding more and more that they're consistently performing at a similar level. And I think a lot of the dairy folks realize how well they can do on milk replacers with good management. So if you go to the, basically if you go to, you can see the rams tend to have some lower numbers. Actually, just notice now that I made a mistake saying the standard was a ram lamb. The standard's actually a single ewe lamb. So she's a 1.0. So you'll notice as the numbers go above 1, that means that weight is being adjusted upward because of the environmental effects of being an older or a younger ewe or a more multiple birth or being a male. So you look at the ram lamb born and raised as a single from a ewe that's 3 to 6 years of age. His weaning weight's going to be multiplied by 0.91, so it's going to reduce the genetic value of his adjusted weaning weight. Adjusted weaning weight is genetic data. The actual weaning weight is the raw data. And even the one that you correct for the age, that's still kind of real data, but and I'm not saying adjusted weaning weights aren't real data, but they're actually getting at the genetics. And so the absolute value of the adjusted weaning weight isn't as important, it's the comparison that's important. As we've gotten breeds involved with EPDs and as they've done large research projects, in some cases they have developed breed-specific adjustment factors. This is an example of the Katahdin breed. I think one of the biggest things they realized with all the data from the Katahdin breed is that the first-time moms, the yearlings, needed a bigger adjustment factor than compared to some of the conventional breeds. If you don't have Katahdins or you don't have a breed that has its own adjustment factors, then you use the ones on the previous slide. Type of birth and rearing. Type of birth, was it born a single, a twin, a triplet, or more than a triplet, a quad? Rearing, how many lambs or kids did she actually raise? A lot of times if a ewe might give birth to twins, and she might lose one, so she's down to 1. She might lose a couple of lambs, so she gets, from a genetic standpoint, there's kind of credit for being a multiple birth, but there's also credit for being raised as a multiple birth. Because obviously, the more lambs that a female is nursing, the more opportunity that they have, or the less lambs that the female is nursing, the more opportunity that individual has for growth. So the adjustments are for the larger litters. Well, what about goats, you ask? It seems like we're always talking about sheep data. Well, there for a couple of years, the Boer goat breed, one of the breed associations was involved with EPDs through the National Sheep Improvement Program, and by using the sheep factors and the data from the EPDs, they came up with some adjustment factors for meat goats. If I was a Kiko breeder, you know, I wouldn't expect these factors to be significantly different. If we ever get large involvement of our meat goat breeds in in doing EPDs, we'd be able to get, to me, better data for this. The goat data actually has some adjustment factors for birth weight, which we don't see in sheep, but they do use it here in meat goats. So let's show you an example of how you would calculate an adjusted weaning weight. How you would take a weight that you did on your farm, or you weighed lambs, and how you would make any meaning out of it. Because again, just having a bunch of weights is meaningless until you make it so that data is comparing apples to apples or oranges to oranges. So we're going to calculate a 60-day adjusted weaning weight for a Dorset ram lamb born on March 1st and weaned on June 10th. He's born and raised this twin. I made the math easy. His birth weight was 10 pounds and he weighed 70 pounds when he was weaned, and he's out of a 2-year-old dam. So those are the steps, and we're going to go through each one of them. So the first thing, it looked like my slides, the font readjusted on this one. Everything was supposed to be in that white box, just kind of as a reminder for the data on this individual lamb, but the font obviously didn't show through. So to calculate his adjusted weaning weight, the first thing we got to know is what his average daily gain from birth to weaning was. So we start with the weaning weight, which was 70 pounds. We subtract 10 pounds for his birth weight, so he gained 60 pounds. And he was actually 71 days old, because that was 31 days in March, 30 days in April, and 10 days in June. Of course, you can use the spreadsheet to calculate that if you want. And so we came up with an average daily gain of 0.85 pounds per day. 0.85 pounds per day is not good or it's not bad. If you're thinking, well, gosh, my lambs gain better than that, or my lambs don't gain as well, you cannot compare from one farm to another, just like you can't compare this lamb born in March to one born in May. We got to get them on an even playing field. So we're calculating here an example of a adjusted weaning weight, but we're only going to compare lambs that are in the same contemporary group. So he's 0.85 pounds per day is his weaning weight, or his average daily gain up to weaning. If we don't do birth weights, we can still make this calculation. It's just instead of calculating an average daily gain, we calculate a weight per day of age. And we can do the same calculation. Okay, next step. We're going to take that pre-weaning average daily gain, which was 0.85, and we want to adjust it to 60 days. 60 days of age. We weighed him when he was 71, but we want to equalize them all so that they're 60-day weights. So I simply take that 0.85, multiply it by 60 days, and he gained 51 pounds from birth to weaning. I add his birth weight back in, 51 plus 10, so 61 pounds. He weighed 70 pounds when we weaned him, but at 60 days of age, he weighed 61 pounds. Common age, we want to make, no matter when we weighed these lambs, we want to know what they would have all weighed on 60 days, or 90 days, or 120, whatever age we want to use. Does us little good to have lambs that are 60 days old, 65, 70, 85. We got to equalize them all to the same age. So we just did it for this lamb. He weighed 61 pounds. That's his 60-day-old corrected weight. It's not actual. It's calculated. Again, we could use weight per day of age instead of pre-weaning average daily gain. We simply wouldn't add the birth weight back in. The next thing we need to do, so we got all the lambs. We've got this lamb's weight at 60 days. We're going to be able to compare them to other lambs in the same contemporary group at a 60-day weight. But now I got to multiply that 61 pounds by the adjustment factor. By correcting the weights to a common age, it's not necessary to weigh all the lambs on the same day, because again, we're not likely to do that. Okay, so he's 61 pounds at 60 days. Let's look at that chart again, and I just pulled out the ram part of that chart. So he's out of a 2-year-old mom. He was born and raised a twin. So, because he's a twin, he gets an upward adjustment. And because his dam is 2, which isn't as good as 3 to 6, it's better than a yearling, but he gets an adjustment, basically 16% adjustment. So the adjustment factor is 1.16. We multiply that 61 pounds times 1.16. His adjusted 60-day weight is 70.8 pounds. It's actually pretty close to what his actual weaning weight was. But we wouldn't have been able to use that number to compare him to other lambs. So the whole point of adjusted weaning weight is to compare him to other lambs in the same contemporary group. It is not to compare lambs from one farm to another. We can only do that with EPDs. This is on farm, our own records. So it's not hard to do these adjusted weaning weights. If you have very many of them to do, you'd probably like the computer to calculate them for you. But this is actually what you're doing. You're adjusting them to a common age and then multiplying them by an adjustment factor to remove the environmental factors. Because again, differences in twins and triplets, differences in males and females, differences in the age of the dam. And then, even then, we still compare lambs in the same contemporary group. Another useful data or performance data that you can calculate from your flock is basically what we call performance ratios. Here all we're looking at is trying to put a number on it. How was that Dorset Ram lamb, how did he compare to the average? You had 15 Dorset Ram lambs. Well, how was his 71.8 adjusted weaning weight? How did that compare to the average of that contemporary group? And that's pretty simple. You just take the average performance, and this doesn't have to be weight. It could be fecal egg count, it could be fleece weight, it could be scrotal circumference, it could be a lot of different things. We're just comparing it to the average performance of that contemporary group, multiplying it by 100 to make it a percentage. We do this calculation in our buck test. Let's move to goats and say we calculated adjusted weaning weights for about 10 different buck kids. So you see all their weights, and again, they were adjusted for age and adjusted for those factors that we talked about. So the average for those 10 bucks was 41.7 pounds. So what was the weaning rate ratio for buck number 6? Where buck number 6 weighed 45 pounds. So we divide 45 by 41.7 pounds, multiply it by 100, and 108%. So buck number 6, his weaning weight ratio, or his weaning weight, was 8% better than the average. So we do that in our buck test for just about every trait. So if he had an average daily gain ratio of 120, that means he was 20% superior to the average in the test. If he had a scrotal circumference of 72%, he was below the average. So these can be real useful ways to analyze the data. You know, and when you think about it, sometimes when you do the adjusted weaning weights, you get all hung up on what the actual number is. What you're really trying to do is take a group of animals and pick the ones that have superior performance. So animals that would have a higher ratio. Again, no matter what the trait we might be looking at. I wanted to give you a little bit of an example of what we do at the buck test. As I mentioned, we put a large selection emphasis on parasite resistance. And I also think as a trait, not just in our buck test but on farms, I think this is a trait that we truly, in a lot of production situations, in a lot of locations, we need to be looking at selecting for this. So how might you go about selecting for parasite resistance? Well, parasite resistance is quantified by fecal egg counts. Fecal egg counts are basically an estimate of the number of worms in the animal's gut. The only way you can get that actual number of worms would be to kill the animal, and that doesn't work really well for genetic improvement. So we do fecal egg counts. We try to do them after weaning to remove the influence of the dam and to remove all those other influences we were talking about. And we do them when they're a lamb or a kid, because once they're an adult, they tend to develop immunity, especially sheep. So we want to do it when they're at the vulnerable stage. And basically we're doing the same thing we did with the weaning weight. we're comparing the fecal egg count, or the average fecal egg count of that individual lamb or kid, we're comparing it to the group average. And ideally, we want to look at least 15 to 25 animals. The more animals in a contemporary group, the more powerful that data becomes, the more accurate it becomes, the more meaningful it becomes. The more fecal egg counts I take, again, the more accuracy, the more predictable that data is. In order for this to work, we have to know that they're being challenged by worms. It's something we've struggled at with our buck test. Low fecal egg counts don't mean the buck is genetically resistant to parasites unless we also have a lot of high egg counts, so that we know there's a challenge out there. The general recommendation is that you have at least a group average of 500 eggs per gram. I would say probably 1,000 would be better. You need to know that that challenge is there in order to know if those differences, in order to separate out the susceptible from the resistant, you need to know that that challenge is out there. And of course, you're going to make greater progress if you're able to use a resistant male. Just like all the other traits, you only want to compare animals in the same contemporary group. When our bucks come to the research center, they're from 20 different contemporary groups because they're from 20 different farms. We do some things to try to equalize them so that we then consider them in the same contemporary group, and I'll tell you what we do on the next slide. One of the things I think that's hard about parasite resistance is when you take those measurements at different times of the year, things are different. That influence of being a twin or a single can still be pretty strong. So you got to make sure you understand those environmental influences on fecal egg count. We don't have an adjustment factor for for that. So just keep in mind, we're comparing contemporary animals, but we could still have some influence on birth type and things like that, or age of dam. So if I was going to select a sire, maybe from my own that I did on my own farm, or maybe the person that I wanted to buy a sire from was doing this on his own farm, you'd want to choose the sire whose progeny have the lowest fecal egg counts. So here we're actually going beyond individual selection. We're talking about some progeny testing. So if you're doing it on your own farm and you have, say, 25 kids from each sire, and you wanted to pull out a replacement buck, you'd pick a buck from the sire that had the lowest average egg count. You're selecting does or ewe lambs. Again, you want to choose replacements from the sire that had the lowest average egg count. So if you've just got a single sire, then I want to choose a replacement that has the lowest fecal egg counts. And again, if you can do more than one fecal egg count, you're going to have more confidence, there's going to be more accuracy in that measurement. Because fecal egg counts are no different than a lot of things. While they are an objective measurement, there is some subjectivity and variability into them. So the more counts I get, the more confidence I have that I'm selecting a genetically superior animal. This shows you what we do in our buck test. The way we get them to be in the same contemporary group is when they arrive at the test station, they're triple dewormed. Not triple dewormed because they need it, triple dewormed to get them in the same contemporary group, to get them basically at a level playing field. So they're given an anthelmintic from each of the 3 chemical classes. If you look in the first column, that was the fecal egg count they had when they arrived. If you look at the June 14th, the second column, after the triple deworming, you can see that egg counts were basically reduced to 0. The 33, the 25, the 150, they're no different really than 0. So that triple deworming eliminated the worms, put all these bucks on a level playing field, put them in the same contemporary group. The other thing that helped make them the same contemporary group, at least as best we can, is they had a 12-day adjustment period. They got an opportunity to adjust to each other, to adjust to a new climate, to adjust to a new feeding program. So they had a 12-day adjustment period. Is that long enough? I don't know. Are they a perfect contemporary group? Maybe not perfect, but I think where parasite's concerned, they're definitely equalized. Growth, maybe not so much, but I think definitely we're able to tickle out the genetics on parasite resistance. We've got the top 10 bucks in the first table, the bottom 10 bucks in the bottom table. There's about 50 bucks on test in 2012. Huge differences in these bucks. Huge differences. You want a resistance in your herd, you want to use a buck like this. You don't want to take fecal egg counts. We'll do it for you. We'll take a lot of them. We'll tell you whether your buck's in the top table or the bottom table. Or you can buy a buck like this. This is probably the only place in the country or the world that you can get a buck with this kind of data. I wish we could have the same for sheep. The hair sheep ram test in Virginia does a little bit of the same thing. We also select for parasite resilience. That's basically the tolerance. You know, can they continue to produce and thrive despite carrying a worm load, despite having maybe even a high fecal egg count? We do this primarily with FOMACHA scores. FOMACHA scores are an estimate of packed cell volume, which is the percentage of red blood cells in the blood. The bar of whole worm's a bloodsucker, so it's indicative of how they're tolerating the worms. Again, you look at our 10 most resilient bucks at the top and our 10 least resilient bucks at the bottom. You see huge differences. The X's represent deworming. You look at the average FOMACHA scores. Again, big differences in these bucks. In order for a buck to make our sale and to be worthy of being sold as a breeder, he cannot excel in one trait. He has to excel in parasite resistance. He has to excel in parasite resilience. He also has to excel in growth rate. So we're looking for balanced selection, not just one or the other. All of them are important. So this is just an example of how we try to select for resistance and resilience. You could do this on your own farm with males if you had enough of them, and also females if you didn't have enough males. You could do this. Every time the goat, the one thing to keep in mind, every time the goat got dewormed, it should have improved his FOMACHA score or his fecal egg count. So that skews the data a little bit. But even without taking that out, you can see that there's huge differences in these bucks. For, again, look at the resistance, huge differences in the resilience. This stuff actually works. And you could do similar things with other traits. This is just an example of our traits. Yes, the X's mean they were dewormed. What about, I'm just about through, which is probably good because I don't know how much more of a voice I have. The title of this talk was Performance Evaluation, and we focused on numbers and measurements and objective and performance. But what about what they look like? Does it matter? I don't ever mean to imply that it doesn't matter what an animal looks like. It does. But I would argue that over the years, we've put way too much emphasis on what they've looked like, when there's not necessarily correlations between what they look like and how they're going to produce. So, but doesn't mean we should ignore what they look like. I hope you don't hear my dog barking. He's barking right now. First thing I want to say, and we do this in our buck test as well, there should always be minimum standards for reproductive soundness and structural correctness. Always. You know, it doesn't do you any good to select a genetically superior animal for parasite resistance, for ribeye area, for prolificacy, if he's only got one testicle, or he's got some other defect that you don't want to propagate in the herd. So when we talk about reproductive soundness, testicles, of course, is very important. You know, and we can objectively measure those, and we typically have minimum standards. They're pretty widely documented for sheep. I don't see that much data on goats in terms of what the minimum size should be. So not only should they be a minimum size, but obviously they should be sound and they should be healthy. Teeth are important too. Again, a soundness. We don't often find teeth defects. Maybe I didn't even mean to put teeth up there. I guess I meant that to be teats. We look at the teeth number and structure on our bucks, and I think that's, again, it's an important reproductive soundness. The udder conformation, those things are very important. We talk about structure. Feet and legs are important. Pasterns are important. The jaw set, overbites, underbites, conformation in terms of you know, basically how the animal is put together. we should look at these things. But basically we're saying that we should look at a lot of the performance things more. If I were to look at where visual appraisal, kind of how you should look at it, I think you kind of got to, again, answer that question of why you raise sheep and goats and where it fits. If I'm a commercial producer, again, I think there should be minimum standards on these, obviously reproduction, but I mean even on some of these structural things, minimum standards. And those standards should be even more stringent for males, because again, keep in mind that the male is going to be responsible for passing his genetics on to so many more offspring than a single female. Perfect example, if I had a ewe or a doe that was a little off in the mouth, I probably wouldn't get rid of her. But I'm going to be more particular on the male. There's probably some correlation with productivity and longevity with some of these visual traits. I think if you remember from last week, it couldn't really find much data to support that. We probably have some of that with the dairy females on the dairy goat side. The other thing I think where visual appraisal comes in is fleece traits. A lot of those traits, particularly on the hand spinning market, are things that we are visually evaluating. So they are still important. So I talk a lot about production and weights and numbers, but looking at the animal and looking at the fleece and looking at the udder conformation, those are still important things. Particularly if I'm showing my animals. You know, again, somebody can say, well, how tall an animal is, well, that's not very important. But the traits that result in animals doing well in the show ring, bringing good prices, private treaty or at consignment sales, those traits are important, and they are economic. Many of them are very highly heritable. Again, couldn't necessarily always find the data to support that, but you know, you select for height, you select for length. I think most of you people know that when you select for that, you are seeing that. But always keep in mind that there is a low correlation probably between a lot of these visual traits, these subjective traits, and productivity. Just keep that in mind. Reproduction is still important in show sheep, but the traits that put the most money in your pocket or help you achieve your goals are still very, very visually oriented. The other thing to keep in mind is that visual appearance and how the animal look is still a very important aspect of market acceptance. Whether I'm selling lambs at a sale barn or somebody's coming to my place to buy a ram, how that animal looks is still very important to them. Even if I talk till I'm blue in the face about performance and productivity, how an animal looks is still important. And because of that, we still need to be aware of that. If you're wondering what breeds are in those pictures, on the left-hand side are blue-faced Leicester. That's from a flock in Maryland. If Nancy's on our, Nancy Starkey's a participant today, those are her sheep from several years ago. The sheep on the right are Hampshire ewes from the University of Kentucky. University of Kentucky has an incredibly good quality Hampshire flock. So that's where they're from. I do still have a little bit of a voice left, and that kind of concludes tonight's presentation. These pretty little lambs are a couple of days old, and they are purebred Katahdins from my farm. So next week, our final webinar, we want to focus on, again, what I call more advanced genetic improvement, talk about EPDs, EBVs, talk about, you know, how you use some of the HIA data for dairy goats. What are some of the things in the future? What's going on with mapping the genome? You know, what individual genes have they identified? Will this ever mean anything to us? That's kind of what we want to focus on next week. I thank you for your willingness to listen to my